Welcome to a lesson on conceptualizing multiplication and division of integers using color counters and the language of copies. We'll begin by considering the product 3 times 2 equals 6. One way to understand this product is to think of this as meaning 3 copies of 2 is 6. Using color counters, below we do have 3 copies or 3 groups of positive 2, which we can see is positive 6. Now that we understand this product, every product has a corresponding quotient. 3 times 2 equals 6 corresponds to the quotient 6 divided by 2 equals 3. 6 divided by 2 is asking how many copies of 2 are in 6. The quotient is 3 because there are 3 copies of 2 in 6, which we can verify from the model below. Now let's consider the product 3 times negative 2 equals negative 6, which means 3 copies of negative 2 is negative 6. Using the color counters, here's our model for 3 copies or 3 groups of negative 2, which once again we can see is negative 6. The corresponding quotient for 3 times negative 2 equals negative 6 is negative 6 divided by negative 2 equals 3. Negative 6 divided by negative 2 is asking how many copies of negative 2 are in negative 6. The quotient is 3 because there are 3 copies of negative 2 in negative 6, which once again we can see from the model below. So if we understand these first 2 examples, we will now try to extend this idea for 2 more products and their corresponding quotients. Here we have negative 3 times positive 2. We will view this negative as the opposite and rewrite this product as the opposite of positive 3 times positive 2, which equals negative 6. The product in this form can be viewed as meaning the opposite of 3 copies of 2 is negative 6. To model this product, let's first review 3 copies of 2. We saw earlier 3 copies of 2 is positive 6, but we want the opposite of 3 copies of 2, and therefore we would take this model and change the sign of the chips or flip them over, which would give us 6 negative chips. Here's a model for the opposite of 3 copies of 2. The corresponding quotient is negative 6 divided by 2 equals negative 3. Negative 6 divided by 2 is asking how many copies of 2 are in negative 6. The quotient is negative 3, which we will view as the opposite of 3 because there are the opposite of 3 copies of 2 in negative 6. And for our last example, we have negative 3 times negative 2. Again, we'll view this negative as the opposite. Rewrite this product as the opposite of 3 times negative 2, which equals positive 6, because the meaning of this product is the opposite of 3 copies of negative 2 is positive 6. To model this product, we'll begin with 3 copies of negative 2. So here's 3 copies of negative 2, which we can see is negative 6. Because we want the opposite of 3 copies of negative 2, we need to change the sign of these integer chips or color counters, and therefore they all become positive. Here's the model for the opposite of 3 copies of negative 2, which we can see is positive 6. And then finally, the corresponding quotient is positive 6 divided by negative 2 equals negative 3. 6 divided by negative 2 is asking how many copies of negative 2 are in positive 6. The quotient is negative 3. And again, we'll view this as the opposite of 3 because there are the opposite of 3 copies of negative 2 in positive 6. Hopefully you found this lesson helpful in conceptualizing multiplication and division of integers. To conclude, the formal rules for multiplying and dividing integers are the same. When multiplying or dividing 2 integers with the same sign, the result is always positive, and when multiplying or dividing 2 integers with different signs, the result is always negative. I hope you found this helpful.